Good morning, students. Now we are going to see the new lesson, Dual Nature of Radiation and Matter. First, we are going to see the concept of particles and wave. That is introduction about the lesson. The next one is electron emission. And the last one is photoelectric effect. We are familiar with the concept of particle and wave in our everyday experience. You see some example of particles: marble balls, grain of sand, then atom, electron are some of the examples of particles. You see some example of waves. Some example of waves. See sea wave, ripples in pond, and sound waves, light waves are some examples of waves. Both particles and waves, they have ability to carry energy and momentum from one point to another. In classical physics, particles and waves are separate components of physical reality. In classical physics, mechanics is particles and optics are learning about waves. Both are traditionally independent subjects, each with its own experiments and principles. Electromagnetic radiation is recorded as waves because they exhibit the wave phenomena such as interference, diffraction, and polarization under some suitable circumstances. Similarly, electromagnetic radiation behave like a particle in blackbody radiation and photoelectric effect. When electron, proton and other particles also that considered as a particles because they possesses mass and energy. So this is behave like a particle. In some circumstances they exhibits wave-like properties also. So in this unit we are going to discuss about the particle nature of waves, that is radiation. Particle nature of waves, that is radiation. And the next one, the wave nature of particles, that is matter. We are going to see only this in this unit. The first heading is electron emission. In metals, the electrons in the outermost cells are loosely bound to the nucleus. Even at the room temperature, there are large number of free electrons which are moving inside the metal surface because they are attracted by the positive charge of the nucleus. This attractive pull will not allow the free electrons move from the metal surface. In order to cross the metal surface, the electrons to leave from the metal surface, that electron must cross the potential barrier created by the nucleus. Potential barrier created by the nucleus. The potential barrier which prevents free electrons from leaving the metal surface is called surface barrier. So, when you are applying the external energy to the metal surface, the electrons are moving from the metal surface that cross the potential barrier and leaving the metal surface. This is called electron emission. This process is called electron emission. What is work function? The minimum amount of energy for an electron escape from the metal surface is called work function. Work function is denoted by the letter pi. The unit of work function is electron volt, E capital V, electron volt. 1 electron volt is equal to 1 EV value is equal to 1.6 into 10 power minus 19 joule. This is the relationship between electron volt and joule. For example, you take the minimum amount of energy for the electron value is equal to 0.7 electron volt. The potential barrier value is equal to 3 electron volt. So how much amount of value of work function? What is the value of work function? Work function pi value equal to the potential barrier minus the minimum amount of energy what they have, the electrons have. So the answer is equal to 2.3 electron volt. The value of work function is equal to 2.3 electron volt. There are 4 types of electron emission is there. The first one is thermionic emission. The second one is field emission. The third one is photoelectric emission. And the last one is secondary emission. First heading is thermionic emission. In thermionic emission side, the metal is heated, the electrons are emitted. Metal heated to the higher temperature, you see the thermal energy is heated, means the electrons are liberated from the metal surface. This effect is known as thermionic emission. Thermionic emission. When the metal is heated to the high temperature, the free electrons on the surface of the metal get sufficient energy in the form of thermal energy. So they emitted from the metal surface. This is known as thermionic emission. This thermionic emission depends upon metal. What type of metal you are taking, that is the nature of the metal and temperature. Few examples for this thermionic emission is cathode ray tubes, electron microscope and X-ray tubes. The next heading is field emission. What is meant by field emission? When the strong electric field is applied, the electrons are emitted from the metal surface. So this strong electric field help the electrons to overcome the potential barrier. So that is called field emission. Some example: scanning electron microscope, field emission display, etc. The next one is photoelectric emission. When the electromagnetic radiation that falls on the metal surface, the electrons are emitted. This is photoelectric radiation emission. Examples: photodiodes, photoelectric cells. Next one is secondary electron. When the fast moving high speed electrons that strikes the metal surface, the free electrons in the metal surface that gains the kinetic energy and liberated from the metal surface. These electrons are called secondary electrons. This is called secondary emission. The next heading is photoelectric effect. In 1887, Hertz did the experiment that is very successful, that is the incidence of electromagnetic waves is given by Hertz. So the high voltage that passed through the induction coil to the metal sphere, electromagnetic waves are produced. The detection of electromagnetic waves, that is the electromagnetic waves are produced, that is detected by the detector that has a copper wire that bend in the shape of the circle. The electromagnetic waves are produced in this side, but the drawback, the spark is produced. They don't know the reason why the spark is produced at that time, but the later it found that due to photoelectric emission. The next heading is Hallmark's observation. He confirmed that the spark produced is due to the action of ultraviolet radiation. He confirmed that. See the diagram. zinc plate, that is in the gold leaf electroscope side. Three cases are there: uncharged zinc plate, negatively charged zinc plate, and positively charged zinc plate. When the ultraviolet rays falls, what happens? What take place inside the leaves? Now, uncharged circular plates. This is a gold leaf electroscope. This is a zinc plate. Now, the ultraviolet radiations falls on the zinc plate. It is an uncharged one. So here the positive charges are created. The leaves are open. This is the first case. The second one, now negatively charged zinc plate, the charge of the zinc plate is now negatively charged particle. Now what happens? The ultraviolet rays falls on the UV rays, falls on the negatively charged zinc plates. Now the leaves are open, that means closely it is, not compared to the previous one. Now the zinc plate is positively charged particles. Now the zinc plate is positively charged particles are now the ultraviolet rays falls on the zinc plate side. Both the leaves are open wider. Compared to the last two, it is both the zinc plate, both the leaves are deviated. So from this observation, it is concluded that the negatively charged particles, the electrons are emitted from the zinc plate under the action of ultraviolet radiation. The last one is Lenard's observation. Here, inside the tube, two electrodes are taken. One is cathode, another one is anode. The cathode is connected to the negative end of the battery, the anode is connected to the positive end of the battery. If the ultraviolet radiations that falls on the cathode surface side, the electrons are emitted. These negatively charged electrons are attracted by the anode. If it is a closed circuit, the current flow through the circuit is measured with the help of galvanometer. The last heading is photoelectric effect. So, when the ultraviolet radiations that falls on the cathode, the electrons are emitted. The emitted electrons are attractive by the anode. Then the current flow the circuit measured by galvanometer. This effect is called photoelectric effect. The current produced in this called photoelectric current. And the electrons emitted from the cathode is called photoelectrons. So the definition of photoelectric effect is the ejection of electrons. The electrons are emitted from the metal surface when the electromagnetic radiations falls on the metal surface. This is called photoelectric effect. So, this class you are prepared about electron emission. In that side, the first one is thermionic emission, second one is field emission, third one is photoelectric emission, and the last one is secondary emission. In the photoelectric effect side, the first one is Hertz observation, second one is Hallmark's observation, and the last one is Lenard's observation. So, now you know about what is meant by photoelectric effect. Thank you, students.